This lesson we'll be covering fractions, which are a math subject that causes the most trouble with students going all the way from junior high all the way to the end of high school. Many students don't ever master the fraction, and what happens is later in their high school career, it really comes to bite them. By the time you get to pre-calculus, if the student is scared of fractions, you're going to start getting long multi-step problems of which a fraction is just a small part, but not the main part. And that's when students tend to melt down or get overwhelmed. So I just want to go over this once and for all. If we can learn what's in this lesson now, you'll never have to think about it again. Okay, so we're actually going to start with multiplying fractions because that's the easiest thing you can do with them, okay? When it comes to multiplying, all you got to do is multiply across the top and multiply across the bottom. You don't need common denominators, none of that stuff. Simply 2 times 4 is 8, and 3 times 5 is 15. Now you'd always want to check to see if you can reduce the fraction. In this case you cannot. So that's all there is to it. So for multiplying, you should multiply across the top and the bottom. One thing that you might see that causes students some grief sometimes is if you have a fraction multiplied by a whole number, like a non-fraction, so 2/3 times 5. Okay, well all you got to do in that case is turn the non-fraction, the 5 in this case, into a fraction by putting a 1 underneath, because 5 divided by 1 is 5. Didn't change the problem. Then we just proceed as above. 2 times 5 is 10, and 3 times 1 is 3. Again, we want to look for reducing whenever possible, but again in this case it is not. Okay, so multiplying is easy. Next, we'll move on to division, which is only slightly more difficult. All you got to do, if you have, say, 2/3 divided by 4/5, is we keep the first fraction the same. We just recopy it down. We switch the division to a multiplication, and then we flip the second fraction over. So instead of 4/5, I'm going to write 5/4. And that's it, basically. So you flip the second fraction, and now we're multiplying, and we just learned how to multiply. That's easy, right? So in this case, we have 2 times 5 is 10, and 3 times 4 is 12. Now, in this case, you can reduce. Basically, when reducing, you just want to try and think of a number that divides evenly into both the numerator and denominator. Okay, well, if they're both even numbers, we know that 2 definitely goes in. So 2 goes into 10 5 times, and 2 goes into 12 6 times, so we get 5 6. Okay, so if you can multiply, you can divide. Now, before we move on, I always like to, at Alexander Tutoring, it's very important that we know why the rules are the way they are. So it might seem a little arbitrary that we just flip the second fraction and multiplied. Why would we do that when we're dividing? So that's a question I'd like to briefly address now. And so I'm going to do it just by throwing something out there. A question I would like to ask is, forget fractions, forget everything we're doing, just use common sense. What is 1 divided by a half? That is, how many times would a half fit into 1? Wait for it. Most students can figure out that a half would fit into 1 2 times, just common sense, right? If I have 2 cups, one's half full, I would have to pour 2 half-full cups into the empty one to get a full cup. Okay, so let's see how the math keeps track of that. So I just said 1 divided by 1/2. So we just used our logic to understand that a half fits into 1 twice, but let's see how the rule keeps track of that. So I'm going to change the 1 into a 1/1. We're going to change the division sign to multiplication, and then we flip the second fraction over to get 2/1. Okay, multiply across the top, multiply across the bottom. 2/1 is 2, which is the answer that we got just from using our logic. So that you can kind of see why we're flipping that second fraction. Let's do another one. I now like to ask, like, how many times would 1/3 fit into 1? Just use logic, no math. How many times would 1/3 fit into 1? Pretty obviously, the answer is 3, right? You could take, if you had a glass that was 1/3 full of water, it would take 3 of those to fill up an empty glass. Okay, so let's just take a look at that. So we're going to make the 1/1. We change the division side into a multiplication sign. Flip the second fraction over to get 3/1. equals, multiply across the top to get 3, multiply across the bottom to get 1, equals 3. Okay? So you can see the math does the work for us. It gets us the result that we thought about. Now what I'd like to ask is, okay, 1/3 fits into 1 3 times. How many times do you think 1/3 fits into 2? Just using logic. Most people can use their logic to figure it out that, well, it'll be twice as many as before. 1/3 should fit into 2 6 times. Let's see how the math keeps track of that. So we have 2 divided by 1/3. We turn the 2 into a fraction by putting it over 1. Change the division sign to multiplication and flip the second fraction as before. 2 times 3 is 6. 1 times 1 is 1 to get 6, the answer that we look for. So I hope you can see now why the rule is flip the second fraction and multiply, okay? It's very important at Alexander Tutoring that we know the why behind everything that we do. It's not enough to just memorize a rule, okay? Finally, let's move on to, ironically, the most difficult thing you can do with fractions, which is add and subtract them. You'd think it'd be the easiest, but it's not. Because this is the case where we do need the common denominator. So before we jump into that, I want to just kind of get into some logic here. I'm going to draw some pies or pizzas or whatever. Okay. The first pie here, I'm going to cut into thirds. So both pies, we'll say, are the same size. The circle is the same size. But the first one I'm going to cut into thirds, and the second one I'm going to cut into fourths or quarters. Okay? Now, if I said that I wanted to add 2/3, so what's 2/3? It would be the pink region, right? And I want to add that to, say, 1/4. 1/4 would be this. So that's the visual. Let me write it in math terms. Let's see. Okay, so what I want to try and figure out is 2/3 as diagrammed by the pie above plus 1/4 as illustrated by this guy. Now, looking at the pies, it's pretty clear that we don't have 3 of anything, right? We can't just add the 2 pink ones to the 1 blue one because they're different. It's like saying I have 2 pencils and 1 pen. I don't have 3 of anything, right? So what we need to do is basically cut the pies so that the slices are the same size. And that way we can add same size slices together. How do we do that? I'll show you. So see the 3 here in the denominator? What we're going to do is steal that, take it to the other side, and we're going to multiply the second fraction by 3/3. What is 3/3? Well, it's just 1, okay? What is 1 times 1/4? Well, it's just 1/4. Point being, the maneuver I just did does not change the original problem, okay? We're still going to get the same 2/3 plus 1/4. Anyway, now I'm going to take the 4, the denominator from the other fraction, and I'm going to take it over to the first guy, and I'm going to multiply him by 4/4. You can see what that did is it guarantees that we get the same thing in the bottom, right? Because you can see we have a 4 times 3 in the first set of fractions and a 4 times 3 in the bottom. Okay, so pulling the denominator from the opposite fraction guarantees what we call a common denominator. Okay, and now we're just multiplying fractions, which is where we started, right? That's the easy thing to do with them. And so that's no problem. So for the first one, we have 4 times 2 is 8 over 4 times 3 on the bottom is 12. Plus, for this second guy, we have 1 times 3 is 3 over 4 times 3 is 12. Okay, and now the last step, what we do is we add the top numbers. 8 plus 3 is 11. And we keep the denominator, the bottom, the same. So that's our final answer. Now I just want to try and do an explanation of this last step here. So what did we do? Let's go back to our pies. We started with 2/3 plus 1/4. And then once we did a little work here, we ended up with 8/12 plus 3/12. Now in theory, those are the same sizes as the original pie. So let's just take a look at that real quick. So what I'm going to do is break the new pie into chunks of 12. Okay, so that's going to roughly look something like this. Okay, so there's 12 chunks, and I'm going to break the other guy into chunks of 12 as well. It's not my prettiest work, but you get the idea. Okay, so 8 12, so I'm going to color that in on pie number 1. If we had 1, 2, 3, 5, 6, 7, 8. Now, if you compare these two guys, look, you'll notice that it's the same amount of pie, right? Even though we chopped it up into smaller slices, it's still the same quantity of pie. And then similarly for the blue, for the other pie, we'll get our blue back here. Now we're looking at 3/12 instead of 1/4. Let's see what that gives us. So I'm going to count up 3 of these 12 slices. 1, 2, 3. And you'll notice it's the same amount of pie as 1/4. We just decrease the slice size. Okay, what's the point? You'll notice that in our 2 pies that we're trying to add now, we can add the slices together because all the slices are the same size. Okay, so in the first pie we have 8 12th slices. In the second pie, we have 3 12th slices. Those are the same size slice, so we're totally welcome to add them together to get a grand total of 11 12th slices. A lot of students like to add the bottom number as well, but you can see that that would be wrong because the bottom number says the size of the slice, the top number says how many of them we get. Okay, if you can remember everything that we did and learn how to do everything we did on this little lesson, you will be in so much better shape for your entire high school career, and you'll just feel way better. Things will go way smoother. Anyway, thanks for watching, and